Hi, today we'll discuss about process equipment in chemical plant. Some typical equipment for chemical process are reactor, distillation column, compressor, gas absorber, heat exchanger and tank. We begin with reactor, which is an equipment where the chemical transformation reaction takes place to generate desirable products. Some common types of reactors are batch reactor, CSTR, continuous stirred tank reactor, PFR, plug flow reactor, PBR, packed bed reactor, and FBR, fluidized bed reactor. Reactor may operate in two modes, namely batch and continuous. For batch reactor, the process occurs in an unsteady state system. The reaction proceeds in a given period of time. Batch reactor is suitable for slow reaction process, small volume production and generation of specialty products. Continuous reaction occurs in steady-state system configuration where reactant is continuously fed and product is continuously removed during the process. Continuous reactor is suitable for long production runs and high-volume chemical. It also is easier to scale up, easier to control, and the product is uniform. Let's take a closer look at batch reaction, which occurs in a batch reactor. Batch reactor is a closed system where no material enters or leaves the reactor. It operates under unsteady state conditions where the condition of the system inside the reactor changes over time. Batch reactor may equipped with stirrer or agitator for good mixing and cooling or heating jacket for temperature control. Continuously stirred tank reactor or CSTR operates as an open system where material is free to enter and leave the reactor. The process operates under steady-state configuration where conditions within the reactor such temperature and density are constant with time. Compositions at the outlet and inlet are also similar. Let's move to plug flow reactor or PFR, also known as tubular reactor. It consists of hollow pipe or tube through which reactant flows. PFR operates at steady-state mode. Reactants are continuously consumed as they flown across the length of reactor. Packed bed reactor or PBR is also known as fixed bed reactor. PBR consists of cylindrical shell with convex heads and positioned vertically to allow flow of reactants, which enter from the top, by gravity. During this process, reactants flow through the packed bed made up of porous catalyst where reactants react upon contact with catalysts to form products. Let's look at the behavior of catalysts inside PBR. For heterogeneous catalyst reactor, the mass of catalysts is fluidized, which means a fluid is passed through a mass of solids, giving them fluid-like characteristics. This allows extensive mixing of reactants in all directions. Now, we look at distillation column, which is an equipment used for separation of two or more mixtures into its individual components. The performance of distillation column is controlled by reflux ratio, which is the ratio of the reflux flow, L to distillate flow, D. It measures of how much of the material going up the top of column is returned back to the column as reflux. The more reflux provided, the better the separation. Distillation columns, DC, can operate in batch columns, where the feed to the column is introduced batch-wise similar to batch operation in reactor. On the other hand, continuous columns relies on a continuous feed stream. There will be no interruption unless there is a problem with the columns or surrounding units. Continuous columns are capable of handling high throughputs. These are types of continuous columns. Binary column feed contains only two components. Multi-component column feed contains more than two components. Multi-product column has more than two product streams. Extractive distillation where the extra feed appears in the bottom product, and azeotropic distillation where the extra feed appears at the top product stream. Some basic components of distillation columns are vertical shell where separation of liquid components is carried out. Trays or plates which are arranged in intervals to enhance component separation. Reboiler to provide necessary vaporization for the distillation process. Condenser to cool and condense the vapor leaving the top of the column. Reflux drum to hold the condensed vapor from the top of the column so that liquid, reflux, can be recycled back to the column.